Hi, this is Spatium, and today we're going to discuss about the UVS, ultraviolet spectroscopy, a technique to characterize the materials, nanomaterials. In this techniques, this is a phenomenon of measuring the ultraviolet beam passing through a sample by transmission or by the mean of reflections. Let us see there is a sample which we are going to characterize. So first of all, we need a lamp, ultraviolet source lamp, which is emitting the various kind of wavelength light. So we need to filter that because we need a monochromatic light. So let's say we are passing that light through a filter monochromator, and then we are receiving the single wavelength light, monochromatic light. So when this light is falling on the sample, some part of the beam are reflected and some part of the beam are transmitted through the sample. The transmitted part is furtherly detected by a photodetector, and this photodetector is recording the intensity of the light, which is after that is characterized or is just represented by the graph of the absorption of light and the wavelength at different peaks. So is the ultraviolet source passing through the prism or filter, and we are throwing that on the sample. Some part is reflected and some part is transmitted, and transmitted part, its intensity, absorption and wavelength are taken as a data, and these data are taken in the form of graph, and then we find out the peaks of the graphs, and then we characterize the material on the basis of that graph characterizations. So the ultraviolet light, we are using the lamp such as the deuterium lamp having a wavelength of 200 to 400 nanometer. Deuterium lamp having the wavelength of 200 to 400 nanometer, or we can use also the tungsten lamp having the wavelength of 400 to 800 nanometers. So whereas in this experiment we have some mathematical abbreviations terms such as the A is for the absorption, C is for the concentration, L is the path length, which is light where the light is traveling through, transmitting by, and I naught is the incident light intensity, and I is the transmitted light intensity. Lambda 1 is the filtered wavelength. Here we have the Beer-Lambert law, which is equals to the A absorption is directly proportional to the C into L, where C is the concentration and L is the path length where the monochromatic light is passing through the sample. So that's it, the sample, the concentration and the absorption of the light into the sample. We are taking sample as nanomaterials, and or we can use also like the protein molecules, etc. In the Beer-Lambert law, where A is equals to minus log I upon I naught, we can solve this equation furthermore, minus log I minus log naught, which is equals to log, because if there is minus sign, so that becomes minus, that becomes plus. So I naught is plus here. Log I naught minus log I, where I naught is the intensity which is taken as 100 as standard value in this characterization in this experiment. Log 100 is 2 minus log I. So finally we get the absorption A equals to minus 2 minus log I. And by the experimental data, we are receiving the wavelength, intensity and the absorption data which are given in this table. These are the database. The wavelength 1500, 1498, 1496, so on. Intensity 0.66, 0.65, 0.64 and so on. absorption 1.34, 1.35, 1.36, and more, so on. So these are the data we are just taking from the experiment, and if we plot the graph of intensity and wavelength from this database, we can find out the many peaks at the different wavelength and intensity which are we are receiving from a different wavelengths. This is the graph of wavelength and the intensity, where on the base we have a wavelength and the perpendicular axis we have the intensity. The wavelength is we are moving toward the right, the wavelength is decreasing, and as we are moving upward, the intensity is decreasing. So this graph here, as well as the wavelength is decreasing, the intensity is decreasing. At this point we get a wavelength, this is the lambda max at the intensity 0.61, and wavelength is 1490. That's, and as further we are passing through the wavelength, we get these peaks. There are fluctuations in the intensity of monochromatic light, which are shown in this whole graph of the intensity and wavelength. So this is the, we can say, the signature of any sample you're taking to characterize. This graph is the signature of its structure and its properties. Use of ultraviolet spectroscopy technique is that we can use this technique to characterize the absorption of materials such as the coating absorptions and the pigments absorption and the absorption on the windows. And further application of this UVS technique, we can determine the molecular weight of molecules. Thank you.